Hey everyone, and welcome to this explainer. I am seriously thrilled you're joining us today because we are going to decode the incredible forces of nature that are currently powering India's sustainable future. We're looking at a massive transformation, how an entire nation is fundamentally shifting its energy landscape by tapping into the very elements that surround us. We're talking the sun, the wind, the water, and the earth itself. So get ready because this is going to be a fascinating journey into the mechanics of tomorrow's power.
All right, let's just jump right into our roadmap. We'll hit the big energy picture first, then look up to the sun and wind, tap into the water and earth, break down biomass, waste, and fuel cells, and finally look at climate adaptation and conservation. Section 1. The Big Energy Picture Frameworks for the Future.
Now, before we even start talking about solar panels and giant wind turbines, we really need a map. And that is exactly what these frameworks provide. On a national level, we've got the IESS 2047, which is this incredibly cool calculator used to explore future energy scenarios for the country. And globally, there's IRENA, the International Renewable Energy Agency. It unites a massive 168 members. Think of it as the ultimate knowledge bank for tech and policy to help countries make this huge transition. These frameworks just make absolutely sure that as the world upgrades its power grid, nobody is flying blind.
Moving on to Section 2, Power from Sun and Wind, Harnessing the Sky. Okay, looking up, you'll quickly notice that capturing sunlight isn't just a one-size-fits-all deal. On one hand, you have photovoltaic electricity. This is probably what pops into your head first. Solar panels using cells to literally absorb direct sunlight and zap it straight into electricity. But then you've got solar thermal electricity. It's kind of different. This uses mirrored collectors to reflect and concentrate the sun's heat onto a liquid. That hot liquid makes steam, and boom, that steam spins a turbine to make electricity. Two totally different routes, but both are incredibly effective.
So why do those two technologies matter so much? Well, it comes down to a mind-blowing number: 5,000 trillion kilowatt hours. Seriously. That is the amount of solar energy hitting India's landmass every single year. To put that into perspective, most parts of the country receive 4 to 7 kilowatt hours per square meter every single day. The geographic potential here is just off the charts, offering huge scalability, especially when you look at high radiation states like Rajasthan, northern Gujarat, parts of Ladakh, Andhra Pradesh, Maharashtra, and Madhya Pradesh. And the thing is, India isn't keeping this solar ambition to itself. They are actively leading the charge globally. Launched at the COP21 in Paris back in 2015, we have the International Solar Alliance, or ISA. It brings together 121 solar resource-rich countries lying between the tropics of Cancer and Capricorn. With its secretariat set up right in Gurgaon, India, this alliance focuses purely on the unique energy needs of those sunny tropical nations. It's growing super fast, too, with Paraguay recently stepping up as the 100th full member. All right, shifting from the sun to the wind, we're basically capturing the kinetic energy of moving air. And just like solar, setting up wind energy comes with a practical and financial choice. You've got onshore wind farms, operating right on land where the wind tends to be strongest. These are definitely less expensive and just way easier to set up and maintain. But then you have offshore wind farms, constructed out in large bodies of water. Now, while they can capture those super consistent ocean breezes, they're significantly more expensive to build than their onshore counterparts. But whether we're talking onshore or offshore, the raw potential here is staggering. We're looking at 302 gigawatts of wind potential at 100 meters above ground level. Gujarat actually takes the top rank for maximum potential, closely followed by Karnataka, Maharashtra, and Andhra Pradesh. In fact, India is already one of the top 5 wind nations globally today, sitting right up there with Germany, the USA, Denmark, and Spain. They collectively account for 80% of the world's installed wind capacity. Let's head downwards for Section 3, Tapping Water and Earth, Harnessing the Deep.
Moving from the sky to the water, there's been a pretty massive evolution in hydropower. We all know hydraulic power is cheap and clean, capturing water flowing downward to spin a turbine. But large hydro projects, like those massive dams at Terry and Narmada, have historically come with some major environmental and social controversies. The modern fix? A smart shift to small hydropower, or SHP. These are projects under 25 megawatts. They're mostly run-of-river, meaning they use a small weir with little to no water storage, so they completely avoid the adverse effects of big dams. They're absolutely perfect for rural areas, and India has identified a massive potential of almost 19,750 megawatts across over 5,000 sites.
But hey, rivers aren't the only source of water power. Did you know the oceans are essentially giant solar batteries? Tropical seas actually absorb solar radiation equivalent to the heat of 245 billion barrels of oil. And we can tap into that using a wild process called OTEC. It goes like this. Step 1, you harness that warm solar heat from the ocean's surface. Step 2, you utilize the huge temperature drop when you go down to the freezing depth 1,000 meters. Step 3, you use that extreme temperature contrast to run a heat engine and generate electricity. India is also jumping into ocean kinetic energy, setting up its first 150 megawatt wave project at Vijanam and planning a massive 5,000 crore rupee tidal project in Gujarat. And then there's the Earth itself. Deep below the crust is molten magma, generating immense heat. India has mapped out 340 hot springs with the potential to produce over 10,600 megawatts of geothermal energy. But here's the catch. Despite exploring this way back in the 1970s, India currently has 0 operational geothermal plants. Why is that? Well, the roadblocks are tough. We're talking incredibly high generation and drilling costs, major transmission barriers, and sheer accessibility and execution challenges. It is a vast reservoir of power, but it's literally locked away for now. Let's bring it back to the surface for Section 4, Biomass, Waste, and Fuel Cells Harnessing the Ground.
Okay, this might genuinely surprise you. Biomass makes up a whopping 32% of India's total primary energy usage. Over 70% of the population depends on it. Now, biomass is energy derived from carbonaceous waste. Think firewood, dung, crop residues, municipal waste. You might be wondering, wait, doesn't burning that release carbon dioxide? Well, yes, it releases about the same amount as fossil fuels. But here is the genius carbon math. While fossil fuels release ancient trapped carbon, biomass releases carbon that it just recently absorbed while it was growing. It's a closed loop, making it beautifully carbon neutral. We're talking 450 to 500 million tons of it available annually, which is an 18,000 megawatt potential.
To actually unlock that power, we have to rely on some pretty fascinating chemistry. First up is biomethanation. This is where tiny microorganisms basically eat biodegradable matter in an oxygen-free zone to create methane-rich biogas. Pretty cool, right? Then we have pyrolysis. This uses extreme heat, completely without air, to literally break organic molecules down into a gas called syngas. This syngas can then be cleaned up and burned in turbines to make clean electricity.
Now, the name of the game here is efficiency, which brings us to cogeneration. This just means producing 2 forms of energy, like heat plus electricity, from one single fuel source. Think of it like this. A plant burns fuel to boil water for a turbine, but instead of letting the exhaust heat just float away, they capture it and use it too. You're basically doubling the utility. Since India is the world's largest sugar producer, the potential is mind-boggling. India's 550 sugar mills could generate 5,000 megawatts of power just by efficiently cogenerating with their leftover sugarcane waste, which is known as bagasse. We also have mountains of urban and industrial waste that could, in theory, be kept out of landfills and turned into clean power. But waste-to-energy faces some really severe operational roadblocks in India. They're dealing with expensive imported technology, huge costs for critical equipment, and, frankly, improper segregation of municipal solid waste is a massive hurdle. When organic waste gets mixed up with everything else, it completely jams up these delicate energy techniques. Toss in a lack of clear state government policy support, and it's a real uphill battle.
Before we leave the ground level, I've got to mention a hyper-efficient, combustion-free technological frontier: fuel cells. These are elegant little electrochemical devices. They take the chemical energy of a fuel, like hydrogen and oxygen, and directly convert it into electricity, water, and heat. There's no burning, no smoke, just a totally clean chemical to electrical conversion. It's an absolute game changer.
Finally, Section 5, Climate Adaptation and Conservation. Because look, building all these wind turbines and solar grids means absolutely nothing if we aren't also protecting our natural environments. Take Kanchenjunga National Park in Sikkim as a prime example. It was actually inscribed as India's very first mixed World Heritage Site on the UNESCO list, recognized for both its natural and cultural heritage. It's a powerful reminder that our ecosystems and our human history are deeply intertwined, and we have to vigilantly protect the whole shebang. But protection takes real resources, and India is financially committing to this reality. The government set up the National Adaptation Fund for climate change with a budget provision of 350 crore rupees to assist states and union territories. This money is specifically designed to undertake targeted, localized projects to help vulnerable areas adapt to the unavoidable impacts of climate change. And that brings us to the ultimate takeaway of this explainer. Generating all this clean power from the sun, the wind, the water, and the earth, it's an absolute scientific marvel. But it's really only half the battle. So the question I want to leave you with today is this. If harnessing nature's power is only half the battle, how will we use that very energy to adapt and actively protect our most vulnerable natural heritage? Thanks so much for exploring these elements of power with me. Keep learning, keep questioning, and I'll see you next time.